You are born to win. What are ultraviolet rays? What are UV rays? You are aware of web yoga. Violet, indigo, blue, green, yellow, orange, red. There are 7 colors that form of sun's optical band of emission. You see these colors in a rainbow or rare sights these days in most urban areas due to dust and excessive pollution. But you can see a similar color ray splitting if you keep a bucket filled with water out in the sun and put a thin layer of kerosene or oil in the water, or you can split the rays with a prism. Red has the lowest energy in the optical region. The colors increase in energy from red to violet. Below red in energy are the infrared rays. Infrared is equivalent to the heat rays that we cannot see but we can sense through our skin. Higher in energy than violet and invisible to us are ultraviolet rays in the upper region of the high energy rays, generally called electromagnetic rays, EMRS. Above ultraviolet rays are X-ray rays, then gamma rays in nuclear reaction in a nuclear power station or during the explosion of a nuclear bomb. You will have lots of gamma rays. The sun emits them too, as do other stars in the cosmos. There are whole sets of scientific research studying the sun's emissions and relating these to a diverse phenomena on Earth. This is still an active research area. Above the troposphere, there are several layers of atmosphere discovered through researchers, mostly over the 20th century. Some of the early rocket experiments from Tumba during the 1960s, for which Dr. Kalam provided the rocket service as an astro engineer, were aimed at studying these layers. Y.S. Rajan used to work as research scholar, then in a physical research laboratory in Ahmedabad. Dr. Kalam, as we go upwards from the surface of the earth, the atmosphere becomes less dense. That is, a number of molecules of various constituents of the air are like nitrogen, oxygen, carbon dioxide, water vapor, etc. decreases. Even 2 kilometers above the surface, the earth atmosphere is noticeably thinner. If you go to Ladakh or to the upper regions of the Himalayas, the air is less dense than in the plains. The air there has less oxygen and we need to adjust to it. When you go to Lahore, which is at height of 3,300 meters, you will be asked to take a day's rest before you move about to allow your body to acclimate itself to the thinner air. If you go much higher, you may need external oxygen support. Beyond 30 km from the surface of the earth, is difficult to operate a conventional aircraft or balloons as the air is very rare. These upper layers of the atmosphere starting around 50 km and going up to 300 km from the ionosphere. Certain frequencies of radio transmission depend on the ionosphere till the last quarter of the 20th century. These bands of the radio frequency waves were crucial for civilian and military use. The global coverage of the radio was brought about AM amplitude modulation. Radio stations like BBC, Voice of America, Radio of Moscow, and others that use high frequency HF and very high frequency VHF waves. Space communication satellites are like huge invisible towers, 36,000 kilometers tall. More about these later. The ionosphere, even at a height of 300 kilometers from the surface of the earth, still has a number of molecules, ions and electrons. These have high speed because of their high energies derived from the sun. Also, the ions and electrons interact with the earth's magnetic field and acquire considerable speed in the certain directions. Therefore, satellites were placed in a orbit of height of 300 km. They would be hit by many of these molecules, ions and electrons, which would lead to considerable friction. The satellite would slow down and also get heated. They would gradually descend in orbit and eventually enter the lower levels of the atmosphere, get burnt up like the meteoroids. To work efficiently, satellites have to be placed in orbit at a greater height of 400 or 500 km. The higher they are placed, the lesser the molecules and friction and the longer life of the satellites in the orbit.